Hello, I am Nitya Pushpasen and today I will be presenting a proposed big data infrastructure designed for Tesco's highly data-intensive retail environment. This project proposes a modern Hadoop Spark Iceberg Lakehouse architecture. The primary goal for this solution is to unify heterogeneous data formats such as CSV, text files, and deeply nested JSON into a single analytical ecosystem. This transition is essential to support Tesco's move toward advanced data-driven decision-making. Tesco operates in a highly competitive retail and consumer goods industry, defined by tight profit margins and constantly evolving customer expectations. Data is integral to their operations as they collect information from club card loyalty programs, point-of-sale systems, and clickstream data from their digital platforms. However, this sheer scale presents significant big data challenges. They face massive volumes of daily transactional data, and they struggle with variety, having to integrate structured POS records with unstructured sensor outputs. For example, velocity is also a hurdle, as real-time data is critical for stock accuracy and dynamic pricing. Finally, veracity issues frequently arise from incomplete or inconsistent data profiles. When we map Tesco's current data landscape, we see a vast ecosystem. They increasingly rely on semi-structured data like clickstream logs and product metadata, alongside unstructured data from LOT sensors, customer reviews, and CCTV footage. Currently, this data is stored in a fragmented hybrid environment, combining legacy relational databases like Oracle with expanding cloud data lakes. This fragmentation creates severe limitations. Legacy systems struggle with scalability. Furthermore, information resides in separate silos, making enterprise-wide analysis difficult, and the reliance on older batch processing designs hinders real-time capability. A major focus of this project was addressing the big data challenge of variety. Specifically, Tesco needs to unify heterogeneous formats such as CSV, text files, and deeply nested JSON into a consistent analytical schema. The proposed architecture achieves this by separating ingestion, storage, and processing. Kafka and NiFi capture the data without rigid upfront schema enforcement. HDFS acts as a schema-agnostic repository, persisting all data to its original form. Then, Apache Spark is used to parse, flatten, and transform these diverse files at scale, while Apache Iceberg maintains analytical consistency and allows schemas to evolve safely. To resolve the bottleneck of variety, the report outlines a modern Hadoop and Spark architecture. The pipeline captures data using Kafka for real-time event ingestion and Apache NiFi for batch ingestion. This data lands in multi-zone HDFS layout. The row zone stores immutable data, while the curated zones uses Apache Iceberg tables to provide ACID compliance and schema evolution. Processing is executed by Spark on Yarn, which efficiently handles large-scale transformations and advanced analytics. Crucially, a governance layer using Kerberos, Apache Ranger, and Apache Atlas ensures the platform is secure, auditable, and GDPR compliant. To prove this architecture works, three distinct datasets were processed, cleaned, and analyzed. The structured Tesco CSV dataset revealed a deliberate brand tiering strategy, highlighting the price differences between premium lines like the Tesco Financed and the core Tesco brand. The irregular global superstore text dataset exposed significant regional variations in sales performance and highlighted that high sales volume does not guarantee profitability. Finally, the deeply nested food data central JSON was successfully flattened, allowing us to generate aggregated insights on macronutrient distributions. All of these insights were then connected to comprehensive analytic dashboards, proving that this architecture can transform raw, unstructured data into actionable intelligence. The three dashboards shown here demonstrate the final consumption layer for the big data architecture. The dashboard confirmed that heterogeneous CSV text files and deeply nested JSON were successfully ingested, cleaned, and unified using Spark and Iceberg. The aim here is not the visual design itself, but to show that the Lakehouse architecture produces reliable, decision-ready analytics for real business use cases. In conclusion, this project shows that modern Hadoop Spark Iceberg Lakehouse architecture offers a strong, scalable, and long-term solution for managing Tesco's diverse data. It effectively tackles the challenge of data variety. And looking ahead, there are clear opportunities to improve the system, such as automating data quality checks and making greater use of real-time data streaming. Beyond the technical aspects, it is equally important that Tesco continues to ensure GDPR compliance, reduce algorithmic bias, and consider environmental sustainability as the system grows. Thank you for your time.